Hi, my name is Moshe, and I would like to share with you how to install Vera. So I have the Vera bits here. Double click on the executable, and we get the installer screen open. And we choose how to install it. Right click next. We say where we want the install to install the software itself, and we say install. So we see it's installing, and we'll get this icon to run Vera later. So that's it. I mean, it's very simple. It's really straightforward. And yeah, and we can say finish, and it will start Vera. So I have several screens here. It started on the other one, so you can see Vera started, and this is the Vera login screen. But before we go to Vera and play with this nice animation, I would like to share with you how to use a model and which model to use. So let's move one step backwards, and I will tell you about my daughter, which actually built an iClient for working with Vertica, and the amazing part is that she didn't write any code at all. She just patiently explained to the model what she needs, and it generated everything for her. It was not the model I'm using here, but it was one of the commercial models like ChatGPT and others she was using, and the model built for her using JavaScript and React. It built this client, amazing work. In Vera, you can connect to any model you like, one hosted online or one or your company already has. You can use this internally, or even a model running locally on your laptop with no internet connection at all. So I choose to use LM Studio. I looked in Google and I download the software, but you can use any tool or model that works for you. LM Studio is a desktop app that lets you run large language models locally without relying on the cloud. It's developed by a small independent team called LM Studio. And the software is free with tons of open source models. You can download it and run whenever you want. One of the great model I was using, before we go into the model I download, let's show you how to find the model. So you go into the search tab here, and you write, for example, 40 billion coder. And when you say search, it will find this coder for you. And the reason I use this coder is this Quant 2.5. It's an open source family created by Alibaba's Quant team. The 2.5 generation is more powerful, and the coder version is designed specifically for programming tasks like debugging, reasoning about code. But we are interested here, at least what my daughter did, is generating SQL from free language, from free text, and this model is good for that purpose. So the 14 billion variant is strong but heavier on memory, while the instruct version follows natural language directions really well, perfect for tuning plain English into Vertica SQL. So you can see the model size is about 9 gig, and it can fit a laptop with 16 gig like I have. And when you run this model locally, you often see something called the Q4KM. So what's the Q4KM stands for? That just means the model was compressed into a 4-bit format, so it fits easily on system with limited RAM while staying accurate. The Q4 is the 4-bit size. The K is the newer improved quantization method, and M is the balanced version that offers a great mix of speed and quality, making it a good choice for running larger models on larger 60 gig laptop. So after you choose and you download it, I already downloaded. You don't see the download button here, but you will if it's the first time. So you download the model, and after you download the model, you load it. So here is the place where you say, I want to load the model. You choose the model you want, and this is the one we are interested in. So I choose it, and then I say load the model. So it will load this specific model for you. This was the one we want. So now you can see it was loaded. It is important to verify because sometimes there is something else loaded. So each time you bring up the app, make sure you load the right one. And after you load it, it will say here status not running or stopped. So you should remember to check this one and to see that it shows running. When it shows running, then you're free to go and continue with the Vera program itself. So after installing Vera, we'll have the Vera icon here. We'll double click on the app. I have a few terminals, so it was open on the other one. So here it is. So this is the Vera app. So Vera is a versatile open source tool for developers, database administrators, and anyone working with the data that acts as a universal remote for a wide array of databases. But this specific version is intended to use with Vertica. And for that purpose, you need a Vertica license, of course. But assuming we have a database running, a Vertica database running, we can use Vera instead of using separate applications. So Vera can provide a single unified interface to connect with and manage and interact with the Vertica database. So in essence, it serves as a comprehensive control center that simplifies database management, development, and analysis tasks within one powerful application. So just we'll see that this app, although it's very powerful, it was developed with AI. My daughter developed this, and I was amazing to see what it can do, and everything was done by AI. So all application logic, both front-end and back-end, must implement exclusively within the Vera JavaScript or React. And the Electron is limited to running the JavaScript code on Windows and backing the application for distribution. So let's log in, and we'll use dbadmin. Although the username and password we are using with Vera is a local user for Vera only on the local PC. There is no relation and connection to the user in the database. So let's see if we try to log in for the first time, what will happen. It tells us user not found, you can create this user. Okay, so let's create the user. I click create, it says user created, you can log in now. Okay, let's do login, and there we go. And for the first time when we log in, it shows us the settings screen. The settings screen is located here when we click settings, and we can choose a folder. So it will be like a local file system folder on our PC. We can choose the one that we want Vera to use, and we choose this one. I could use any folder I want. And yeah, and we have also the client for the Vertica database. We define here exactly where the location of the vsql client, and where the database is located. So my database runs on my local PC, so this is it, but we can write here the IP address of the initiated node we want to work with, or load balancer if it's a floating IP, whatever. And of course we can write here the database name and which user we want to use to log into the database, and the password for this user. And we can test the connection with those buttons. We can also write the location of the AI model on which system it is running. We can write here the IP address, and after we finish, we write save, and yeah, and now we can continue to work with the database. So when we run Vera for the first time, you see that no schema is loaded. Those schemas and tables and stored procedure and everything can be loaded from cache, from local disk on our local PC, but since it is the first time, we'll click refresh. Now it goes to the database and query all the schemas you can see here, stored procedures, system tables, and we have here options to go further. Let's say we choose this schema and it has 3 tables, and we can see for each the columns and the data types, and we can choose things we want to do. We can, for example, run code. So I choose one of the default example queries that comes with the database, and we can run it either by clicking Shift and Enter, or by clicking on the button here, Run SQL. In both cases, if we just click on a partial text, it will run only this text. Let's see, for example, if I will run here select 1, and I will just select this text, and then I will hit Shift Enter, it will run only this statement. And if I will not select anything and I will just hit Shift Enter or Run SQL, it will run all statements that are shown in the editor. And when we want to run a query, we can, for example, select a table we want to work with, and then when we write select, it will show us the completion relevant for the items we select on the schema tree. As you can see here, we have syntax related to the select statement and also columns that are available in the selected table. So we choose this one, and you see that it completes the column name so we can either choose or click, and here we have the table name again. So we can choose from the menu, or we can do something else. We can go here and just stand on any item. It can be a table, a column, whatever. And when we we do right click on the item we stand on, you can see we have schema tree action. So one of the possibilities is just to click on one of those, and it will copy paste the selected item and write it at the place where the cursor is in our editor. So we can continue and do like something like that. Online sales, we choose online sales, and now we can run again the query. And as you can see, I hit Shift Enter or run SQL, and we get the results in the result window. And we can do other nice things. For example, when we click on a table, you can see we can go and see the projections for that table. So let's clean this and see again. We can go to view, and we can say clear all, and we want to do it again. So let's stand on one of the tables. So we can choose the online sales, for example, and I want to see the projections, how they look like for that table. So we have the schema, the table name, projection. We have other interesting stuff like the column name, the encoding, everything you want to know about this projection. And we can see also how it was defined. We can see the create table. We can see foreign key or any other definitions for this table, and also how the projection was created. And you can see here it is ordered by. Let's see how we can produce graphs with Vera. We can choose a schema. There are a lot of schemas here. Let's go with online sales. Several tables here. Let's go with the fact table here. There are some columns, and let's say we want to see how the data is distributed on the provided key. So we can just click graph, select the column, right click on the column name, and in that menu we click graph. And there you go. We see how the data is distributed on this column. We can zoom in, as you can see, and yeah, and scroll, see how enormous amount of bars behaves when we do the group by for that column values. We can also create graphs on specific other columns. Let's say we choose those guys here, and we click right click, and instead of graph, now we have graph selected columns. And I'm expecting to see like a new tab is created and show us by default the scatter information. And we can also ask for bars and see how it behaves. We can do a full window here, and yeah, and we can zoom in for that particular numbers. We can see there are huge numbers here. If we want to see like the small one, we can move left or right and see. You see the numbers, the scale is changing according to the values in those columns. We have a demo button here. So we have a graph like network graph and other graphs here, and we'll have some more in the future. So let's see what happens when we click on the Sigma network. The Vera app creates two tabs here, one with a script that will generate data. Let's run it. I click on Run SQL. We see it runs. It takes several seconds to generate all the data in this demo. And now we will run a query. It can be any query as long as we have enough data for this kind of graph. And then it's called a network graph or Sigma graph. So let's see how it looks like. There you go. This is the graph, and we can play with numbers here, and we can move it so it will be easier for us to see how it looks like. And let's separate the nodes to communities. And now you can see that if we want to see who is connected to who, we just hover about those nodes that we are interested in, and yeah, and we can see the members that are related to each. It can be a cellular number, it can be health information, or whatever data we are looking to see the influence in the network on other members. Let's see the demo. Let's see the demo for the airbed collision and I will tell you what it's all about. So we have here two tabs when we click this airbird collision risk. So we get this script in the first tab that generates the data for the geograph. We create temporary table, we insert some longitude and altitude, we generate this data for planes and birds to make sure they don't have a risk situation and see the visual how it goes. So first we run it. So we just run the script, and as you see, it's running here. We see the elapsed time, and we see when it finished, no errors, and we can go and see the graph. We don't have to run it, the graph will do it for us. So we say visual, and we click on 3D geograph, okay? And now it will bring up our default browser, as you can see here. And yeah, we have Earth, and we have airplanes, so we can track each airplane, how it moves over the map. The reason there is no much details in the map is because it's all offline. I didn't download the maps. Everything is done offline, so we can scroll to the airplanes, we can scroll to the birds and see where the focus is flying, and give us some visualization about the situation for the info we just run the query for. And we can do it also online to get info for ongoing pipeline information that is loaded into the database.